I wanted to present to you an uncommon opinion on climate change. Though uncommon, it bears the resemblance of common sense. This opinion is based on ice core temperature data. The best temperature data, historical temperature data that we have. It's based on proxy data that we find in layers of ice. Proxy data is data that we can use to infer temperature. It's not the temperature itself, but can infer temperature. And these ice cores can be corroborated with deep sea sediment cores, which also can be used with proxy data to match this temperature data. You see the exact same patterns. It corroborates this is the best historical temperature data that we have, and for that reason it is the data that everyone uses. Historical data is important because the patterns of the past help us to predict the future. You can see here 4,000 years, 10,000 years, and 400,000 years of ice core temperature data. So if we're going to try to predict the future, let's look at the past. So we got 4,000 years, 2000 BC to 2000 AD. This graphic is useful because we see the temperature and large-scale human events placed upon and related to this temperature data. For example, you see the Roman warm period. It tracks the expansion in the fall of the Roman Empire, the fall into the European Dark Ages, which resulted in massive death of the human population. Also see the Little Ice Age. This is a period of history not too long ago, which we have good historical information on. You can do some research yourself. There's some good documentaries out there. But to summarize, the prolonged cold, dry periods in the Little Ice Age brought drought upon many European communities and resulted in poor crop growth, poor livestock survival, and increased activity of pathogens and disease vectors. Got it? Cold results in poor crop growth, which results in poor nutrition, famine, starvation. Poor nutrition results in illness. This Little Ice Age was not good for humans. And the reality is that none of these cooling periods have been good for the human population. So what we see is these warm periods, declining pattern of warm periods in the past 4,000 years. See a declining pattern, remember that, in which we are in the last warm period. Let's look at 10,000 years. Okay, you can see this same pattern. This is the 4,000 years here. This is the Little Ice Age. So you see 10,000 years here. You might think this was normal, that this was the normal average. But that is not the case. Past 10,000 years is a rarity. It is a special period called an interglacial, which we can see on this graphic, which depicts 400,000 years of ice core temperature data. This is the 10,000 years that we just looked at. Okay? What we see here is roughly spaced every 100,000 years, what we call an interglacial period. These periods here that dominate the past 400,000 years are called glacial periods. We are technically in an ice age still, because the past 400,000 years have been dominated by glacial expansion with brief interglacials where glaciers retreat. So this is us right here, 10,000 years. All the civilization that we know about right here in this itty bitty history. So let's think about this. Got about 10,000 years here, about 10,000 years here, maybe 5,000, 5,000. What's in between every one of those? About 90,000 years of glacial period. So this is the Little Ice Age. We're talking about a few hundred years. We're talking about crop failure, famine, that kind of thing. It doesn't quite compare to these periods, because in these periods the glaciers grew, covered massive portions of North America, covered massive portions of Europe. Not that you have crop failure, it's that you can't grow crops because the land is covered in ice. You have an entire climate change. The climate of Canada gets pushed south all the way into southern US and into Mexico. The climate gets drastically altered. The ability for us to produce crops changes drastically. The land area to produce animals decreases drastically. And might I remind you, 90,000 years? 90,000 years. That is massive when you think in terms of human history. And let's look at this 10,000 year period. What's the pattern? What's the direction, the trajectory? Peak down, peak down, peak down. In other words, this interglacial is coming to an end, which is what you'd expect. We've already had a good 10,000 years of unusually stable temperature, longer than the others. What we would expect from history, from the past 400,000 years, is a fall back into 90,000 years of glacial expansion into a glacial period. So, what's the uncommon opinion? The uncommon opinion is that global warming due to CO2 emissions is not what we should be worried about. Not by a long shot. What we should be worried about is the historical pattern of falling into 90,000 years of a glacial period. In fact, if the premise is true that CO2 increases global temperature, we should welcome it. Now, that's not a common opinion, but the historical pattern should tell us that this is common sense. Use the historical pattern. Don't use climate models. Climate models are only best guess formulas of how climate operates. They are not data. Use the past to predict the future.